Okay, so the goal for today is to understand the term resistance and to see what factors affect the resistance of a wire and to be able to calculate the resistance of that wire. The term resistance, coined by George Simon Ohm. We'll look a little more about what Ohm did when we study Ohm's law in a future class. The unit, though, for resistance is going to be named after Ohm and will be indicated by the symbol omega. Okay, so when we look at the factors that affect the resistance of a wire, one of those factors is what the wire is made out of. It's the resistivity of the wire. So silver has a low resistivity, and things like nichrome and carbon have a larger resistivity. In lab, we studied how did the length of the wire affect the resistance, and we found it to be a linear relationship, meaning longer wires have greater resistance. We did this for two different thicknesses, and we found that thicker wires have less resistance. When we put all of this together, we find that the resistance of the wire is equal to the material, the resistivity of the material, times the length of the wire, divided by the area of the wire. Area is what we get from thickness. So as an example, see if you can calculate the resistance of 30 meters of nichrome wire that has a diameter of 0.2 millimeters. Your process here is to take the diameter of the wire and cut it in half to get the radius. Take it from millimeters and turn it into meters. Once you have a radius in meters, you then use the formula for area. You then use that formula and get the area of the wire. That is an area of the wire's cross-section. You then take that area and put it into the bottom of your equation for resistance. We're going to use nichrome, which has a resistivity of 1 × 10⁻⁶. The length of the wire is 30 meters, and it turns out that the resistance of this wire is 955 ohms. Sometimes when we look at the thickness of a wire, it's given to us in terms of a gauge. You'll notice that 0 is the biggest wire, and on this one, 30 is the smallest wire. So gauges work in the reverse order. Larger numbers mean thinner wires. Here's a chart that's handy to have. This will show you the gauge number and the diameter in millimeters. So I'd like to see if you can figure out the resistance of these two different jumper cables. The first set of jumper cables is copper, and these jumper cables have 20 feet length and they're 2 gauge. So you go back here to gauge, find 2, and this would be the diameter of those wires. Okay, those jumper cables cost you 85 bucks. A cheaper set of jumper cables is only 8 feet long, but it's 10 gauge. They cost about 10 bucks. These are made out of aluminum. So find the resistance of these jumper cables. If you do this problem properly, you'll find that the aluminum jumper cables have 4 times the resistance of the copper. If you have any trouble with this equation, check with your teacher to make sure you're using it properly. So do this twice. Both times you're using this formula. The resistivity is your material. This is your length. Make sure you turn it to meters. And this is your area, which you get from pi r squared.